Alright, so welcome everybody to week 10, day 1. I'm currently trying to figure out what happened with the Sock Goblins. The kitty code was referring to a piece of the body of the Sock Goblin, and when I deleted it, it stopped working. But now the Sock Goblins are not taking damage. So what happens is these things collide with them, but yeah, I mean, it looks kind of cool too, right? Like, you can shoot this up and the thing snaps over and, you know, launches itself at the target. This thing's not taking damage. So let's see if we can figure out why this is. Okay, lighting needs to be rebuilt too. Okay, dual lighting. Okay, so alright. Maybe I shouldn't have built lighting. Come on. Come on, you do it. Alright, so how you guys doing? Let's unlock down the channel if it's locked down. Unlock it down. There we go. So how you all doing? Tell me how the homework assignments have been going for you. Pretty straightforward, I think. You know, basically every class we learn something new in game development. You guys do it, submit it on Canvas. Like, is the process working, you know, pretty well for you? Got sick over the weekend. I'm sorry. I hope it's not the Rona. So yeah, I mean, I think this class has been going pretty smoothly actually. Okay, so if I lock on, they'll smash into it, but he does not take damage. So if we look at the kitty, you had problems with animation and mesh compatibility, which created horrific things. Yeah, it'll do that. Already caught COVID, just session cold. Yeah. Okay. Had to redo the AI. Yeah. All right. So what's happening here? When we're hitting something, why don't we first see if it's like registering a hit with the Sock Goblin? Because I think the Sock Goblin is set to register hit events, right? It's generate hits events. Yeah, it's set to block all. So it should stop the kitty. The kitty itself hasn't changed at all. It's set to generate hit events. Okay. The mesh. It's always walking. Yeah, this is the worst thing of Unreal Engine. Like, I copied and pasted the Sock Goblin, and I changed the body from that placeholder to the skeletal mesh, and it broke the kitty because the kitty, I did something bad, which was I pulled out the body of the kitty to lock onto, which isn't necessarily bad, but when I deleted the body, the square, you know, of the square Sock Goblin, it no longer existed, and then this stopped working. So I just replaced it with the root component of the Sock Goblin, which is, you know, let's see if we can show it. Yeah, it's the origin of it. And so that works fine now. Oh, maybe this one. Read the value of the variable cube. What are you? Cube. Oh no, that's me. Okay, never mind. Yeah, it's not the, has nothing to do with the goblin. So the cat seems to be working right, but let's just try this. Let's try print string and see if we can figure out what exactly is going on here. So the person we hit, we're just going to drag that in there. It automatically pulls that get display name, and then we'll see if we can figure out why this thing is not working. So if I shoot this at the ground, prints out landscape, Sock Goblin 2, Sock Goblin 4, Sock Goblin 2. I died. Yeah. Cube. Floor, yeller. It's bouncing off me. I have it set to ignore me. Okay. So it is registering hits on the goblin. Okay. So that's what I was curious about. So, and then it's we're saying if we if we hit another kitty, then we just kind of ignore it. Q. So if the person we hit is a kitty, we ignore it. If it's not a kitty, then we make sure they're not the main character, which is another way of doing the same thing. We could just cast it to the main character as well. Then, so it's exploding on the Sock Goblin, and then it's doing apply radial damage. And it's the apply radial damage that is not damaging the Sock Goblin. And the only thing that it's set to ignore is the player character. It should not be damaging me. And we got base damage of 50, damage radius of 300, which should be big enough to hit the Sock Goblins. And then it destroys itself. But the Sock Goblins, as far as I know, are not taking damage. Let's try this over here. Let's go to the event graph, go to event radial damage. Let's just pull this off here. Event string. Hello, sure. So every time radial damage gets called on a Sock Goblin, let's see if we can figure out. No, it's not receiving the event. See that? So even though we're hitting him in the face, it's not taking damage. So strange. Sock Goblin can be damaged. Set to true. See, there's a lot of places where these things can hide. You know what I mean? It can be damaged. Set to true. Doesn't have a max lifespan. Generates overlap events. Hidden. AI is controlling it. Health is set to 60. And it's, but this is, okay, let's try that. Let's see if deleting the event and recreating it would solve something. Is that, there's sometimes a bug like that. Nope. It's still not taking any damage. Kitty is doing radial damage. Let's see if Kitty is saying if it's hitting anything. That string. Because this was working before, right? Like, this code, the only thing that I changed was the mesh to a skeletal mesh. And it's a strange bit of alignment there. Kind of like how it was before. So let's just do that, and let's call this Kitty. And, no. That's not right. So we're going to print if the kitty inflicted damage on anyone. True. 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 False. True. Huh. I wonder if it's like blocking visibility. I'll have to take a look at it later. I'll report back to you what the cause of this thing, because this is just not getting triggered here. Maybe instead of event radial damage, we can just do event damage. Any damage? Let's see if that's... And we could feasibly just, yeah, let's just do this. All right, so let's just do a multi-sphere trace. Okay, so starting at our location of the hit, ending at our hit location, radius of, probably should be variable, promote variable, explosion radius, let's set that to be 3 meters. Trace channel visibility, trace complex off, we don't care how precise it is. Actors to ignore is going to be the player. Draw debug type, let's just draw it for a frame for now. And then this is going to be everybody we hit. So for everybody we hit, we're going to do a for each. So for everybody we hit, we're going to do a for each loop. And we're just going to inflict damage on them. And we'll just do apply damage. We'll just directly damage them. The person we're going to hit. Split. There we go. So the array element hit actor. And that's the person we hit with our radius search. And when we're done, we're going to destroy the kitty. So for each loop, we're going to go over every person within a 3 meter radius, and we're going to apply damage to them. And this might try applying damage to the landscape, which on Quake will crash it. Let's find out if this crashes. Yeah, that worked. Did it work? No. Wow, look at that. It is not damaging them. How? So that means this guy's just not taking damage anymore. Oh, base damage is set to 0? Thank you. Thank you. Alright. We'll set to 34, so we'll take 3 shots. Thank you. Alright, let's try it now. Here we go. Yes, they're taking damage now. Oh, it's one shot killing them. It's a bit odd. Why is it killing them in one shot? Oh, it's hitting it multiple times. That's odd. You see that printed hello twice. So why did it hit the same actor twice? Let's print out how much damage we take. So every time it does it, it's hitting them twice. Yeah. So this sphere trace here is inflicting damage twice on each object. So strange. Turn the damage down to 10. We can figure this out. yeah, it's hitting it over and over again until the person dies. I wonder if it's like hit actor. I wonder if it's like returning each of the body parts or something that it hits. It's probably what it's doing. Yeah, yeah. It's gonna be returning every hit on the person, so they're exploding. Huh. Yeah, that radial damage function sure is useful, isn't it? So we're essentially recreating the radial damage function here. Probably could work more on this. It's starting to get kind of annoying to deal with. Yeah, the traits, if you draw it, here, let me draw it for a duration of 5 seconds. Wait, what you're going to see is it's actually going to return, watch. You see all the different points where it hit? And so it's inflicting 10 points at each one of those locations. Right? Not useful. Yeah, and what's just really weird is that, you saw it all working before, right? So inner radius. Okay. Some truly mystifying conundrums going on down here. Yeah. See, I feel like there's some disconnect here. I don't know. Where the radial damage is not finding the Sock Goblins. Okay, so the base damage will be 50. We'll do a minimum damage of 10. The origin of it is going to be explosion point. The inner radius will have, so the inner radius is where you do full damage. Full damage will be 150 centimeters, and then the fall off, it will fall off to about, I don't know, 5 meters. Fall off exponent. Damage causer is us. It doesn't matter. It doesn't matter. So my guess is that there's something blocking it. Is my guess, and that's the reason why it's not damaging it. But let's try this. Okay. Trying a different radial damaging function. Not taking damage. You see that? I mean, it's kind of cool. Watch. It's a heat-seeking missile. Kind of cool, right? But it's just not doing damage. Set can be damaged. It's just the radial damage is just not finding the Sock Goblin. There we go. Yeah, it was the visibility. Can you lock on? It's not locking on now. Oh, look at that. Trace lines are going right through them now. Okay. Let's see here. Mesh. Yeah, the trace lines. Why are the trace lines going through it? Name character. So I've designated him as a target. This can come flying in and whack in the back of the head. And that one didn't explode. And that one didn't cause damage. And that one didn't cause damage. And that one caused damage. I wonder if it's the cat that's blocking it. I wonder if the cat is actually blocking the explosion. Let's ignore our stealth as well. No. Lock on. Yeah, it's weird. Okay, that's enough debugging for now. It's half an hour of your life down the drain. It's working one moment, broken the next. Yeah, exactly. And like I said, one of the semesters where I was teaching the pathfinding thing, I showed, if you change the parameters on the pathing, like, you can turn You can turn the if you hit P, it shows you the areas that it can path to and not. And I changed it so the step sizes were different. And I showed how you can go up bigger steps and things like that. And then I hit undo, and the whole thing broke. Like, it didn't, like, even when I undid back the way it was before, it just, the thing refused to generate pathfinding over the world. And I was just like, I changed all the settings and hit undo, and ended up having to just quit out of the project without saving and then relaunch it, and then it started working again. So it's just the weird, like, I don't know. I don't tell you. Okay, so what do we need to learn now? We did physics volumes. We did that. Let's talk about your project. I think we're getting to a point where we've got like the basics of a game. Like, you can make monsters, you can make weapons. You know how to do hit scan. You know how to do projectile weapons. You can make a world. You can make landscapes. You can make objects in the landscapes. You can have things when you touch them do other things. Let's talk about your project. So there's two big projects. We got 8 weeks left, so you're fine. There's two big projects to be done by the end of the semester. The first is a mod of some sort, and the second is a Unreal Engine project. So your Unreal Engine project is basically going to be this. You're going to make some sort of game, an Unreal Engine, and have a heads-up display, have sound, have fog, have landscape, have some sort of objective. Like, just basically keep doing what you're doing with this, but turn whatever it is you're doing into a game. And you're going to pitch me a project idea that'll be due next week, let's say. So I think you basically have all of the... I think you've basically got all of the tools in your tool chest. You know, there's obviously more that we can learn about lighting and how to make the sun go down and make clouds move in the sky. Like, there's all sorts of like details like that. But I think that the fundamentals you guys got at this point. You put objects into a world, have them move around, have them do damage, have them take damage, which apparently doesn't always work. And you can start thinking about it now. It'll be due next Tuesday, and you just have to put together a little one-page proposal, a pitch document. So imagine that I'm a publisher, like Take-Two or THQ or ZeniMax or one of these companies, and you're a developer, and you're maybe heading up a team of 5 talented individuals, and you want to pitch me on an idea for a game. And you're asking me for money. You want me to give you money, and you will develop a game. Okay. And so there's a certain art to doing pitches, and there's a GDC video pitch. Why your pitch sucks. 30 things I hate about your game pitch. So your homework for next time is to watch this video and talk about the lessons you learned from it. Okay, so that's your homework assignment. It's how to write a pitch for me. The pitch will be due next Tuesday. For Thursday, all you have to do is just summarize that video. Okay. GDC is a great resource. GDC is the Game Developers Conference. I've taken students there before, and you get to meet people that have made video games and talk to them and see what they're up to, and you learn all sorts of stuff about how to make materials and sounds and all this kind of stuff. So, yeah. Okay, so your project though will basically be this: build a world. You know, it's so open-ended. I don't even want to say there have to be monsters in it that you fight, because it doesn't have to be. You know, students have made games before that are purely puzzle games with no combat. You know, and so sky's the limit. All of you guys have played video games, I think, right? Has anyone here not played a video game before in their life? Crickets. Okay, so I'm going to assume you all have played video games. And I'm sure all of you at some point have had that moment of like, you know, wouldn't it be cool if we had a video game where we could all play spiders and cooperatively make webs together? Wouldn't that be cool? So whatever that dream is for you, just pitch it, and I'll tell you if it's too ambitious or not ambitious enough, because it needs to be scoped appropriately. One of the biggest problems students have when proposing video games is they don't know exactly how much time it's going to take to do them. Okay, so just propose something, and I'll go over it with you next Tuesday, and I'll tell you if it's reasonable or not. Sometimes students scope it too small. I'm going to make tic-tac-toe. No. You need to do more than tic-tac-toe. So I'd like for you to use Unreal Engine for it, and I would like for you to demonstrate to me your mastery of making materials and playing sounds and doing a heads-up display and all the components we've done here. Okay. You're gonna make Pong. Yeah, no. Although, I don't know. If you make a good twist on Pong, like it could be fun. Like, the core game mechanic of like tennis is, it's fun. Right. Okay, so that'll be that. And then the other project you have to do by the end of the semester is your mod project. And the mod project is, we'll talk about later. We're going to probably start getting into that, actually. But for now, you're going to focus on your Unreal Engine project, and the mod project will be the last month of school or so. Okay. So, what goes into a good pitch? Well, there's this notion of something called an elevator pitch. An elevator pitch is that you walk into an elevator, the boss of THQ is there, you got the time that it takes for the elevator to get up to the top floor to get them excited about your game. And so if you were to pitch them by doing something like this, like, hey, when I was in middle school, I had this dream, and I had this friend whose name was Thomas, and Thomas and I used to meet at lunchtime, and we would play video games. And we would always, bing, door opens, they leave. You have said absolutely nothing about your game. Like, they don't care who Thomas is. They don't care that you used to play video games. If you're working for THQ, you probably play video games. You know what I mean? Like, yeah, they don't care. What is your game? What does it do? What is going to make it fun? What makes it different? What makes it interesting? I want to make a first-person shooter that's Call of Duty, but worse. Yeah, that's not going to sell any, public speaking will come in handy for this. Sure. Salesmanship, marketing, public speaking, it's all useful. One of the most useful classes I ever took was ROTC, Air Force ROTC, which had us stand up in front of a group of people and give speeches. And they would criticize you positively on your posture and what you're doing with your hands and things like that. And it's not something that you get in normal life. That's not a normal thing where they teach you how to speak in public. It's a very useful skill. So what you want to do with your pitch document is get me excited for your game. What makes your game different? What makes your game unique? If you're just copying Call of Duty, that's boring as F. Okay? I don't care. Like, I want to make Gears of War, but worse. No, that's why. No, I would just play Gears of War. Like, Yeah, for sure. If you're an independent game developer, which you are, you don't have the resources to go up against the AAA titles on their own terms. You have to find something new and different. Look at Portal. Portal used the Source engine made for Half-Life 2. It didn't have any combat in it, really. I mean, it had some turrets that would shoot you, but basically there's kind of no... Yeah, and if you really wanted to, you could tip him over by throwing a boulder at him, or a rock, or a box at him. Basically, there's no combat, right? So Portal was an indie game where the core mechanic, the core thing... Have you guys all played Portal, by the way? Portal 2? If not, you're going to be staring at me with confusion. But the core mechanic of Portal was that you could open a passageway from one spot on the map to some other spot on the map, and you could actually look through it. And if you opened a portal on one side of the door and a portal on the wall behind you, you could actually look through the door and see yourself from behind. And if you walk through it, then you walk in the back side of the door. If you walk out one way, you come in the other way. Is pretty. That's it. That was the mechanic. The team that made it demoed a game called Narbuncular Drop that I don't think anyone's ever played. But that was the core mechanic. The core mechanic was that you could open a portal in a wall and in another wall, and then you could walk from one to the other. That was it. That's the whole thing. And Valve was at this game demo night, and they're like, what? You know, just that one core mechanic got them all hired by Valve, and then Portal went on to be one of the most beloved games of all times. So it's just a puzzle game, right? And so they just have ever-increasing difficulty of puzzles where, you know, you have to... There's a pit of fire, and, you know, in an easy puzzle, you just create a portal on the other side and a portal on your side. You walk through and you appear on the other side. You know, in later ones, you know, it won't let you create a portal on the other side. Only certain textures you can create a portal on. But, like, there'll be a pit, and you fall into it, and so you create a portal at the bottom of the pit, and you create a portal up here, and you fly down at high speed, you fly out of this at high speed, you jump over the thing, and you succeed. And so it just has ever-increasing puzzles, and that's it. That's the entire game, and it went on to become an absolute sensation that spawned a sequel. And at some point, I assume they'll make a Portal 3, except Valve can't count to 3. Half-Life 3, You know, Half-Life 2, Episode 3, Portal 3, You know? So, it's... Yeah, but that... Do you understand what I'm saying? Like, as an indie developer, they didn't have, like, the ability to make, like, BioShock Infinite. You know what I mean? Like... Left 4 Dead 3. Well, which just came out, right? It's called Back for Blood. Right? Which is Left 4 Dead 3, right? Has anyone here played BioShock Infinite? What did you think of the graphics in it, Torres? Pretty nice. Pretty nice. Yeah, they got like freaking airships and like statues, and they got these rails that you can like lock onto and slide along, and it is just a gorgeous game, full of detail, full of floating cities. It is a masterpiece of art. You're not going to be able to do that. You know what I mean? Like, you're not going to be able to do that as an indie game developer. HUD here is pretty minimal. You could probably do that part. Make a HUD. And if you get some sort of like procedural city generation thing, you could probably procedurally generate, you know, pretty samey looking blocks of cities, you know. But all these signs, you know, all that's art. You know, all of these are assets, delicacies and meats, groceries and meats, hot dogs. You know, this flower hat, these bushes, these railings. All of these things are art assets that you just don't have as an indie developer. You can purchase asset packs off the store, but that's that water tower. Like, it's just like, if you go through and enumerate, if you count how many different dresses and just it's ridiculous. It's absolutely ridiculous how much effort went into making that game. And if you watch the credits for BioShock Infinite, it goes on for like a long time. Like the credits, programmers, yeah, there's more than one. You know, the credits, like, it just keeps scrolling. Hundreds and hundreds of people worked on it. Yeah. So, just wondering how they had the whole graphic system and rendering. 10 minutes? What's 10 minutes? Game of the year. Oh, the end credits. 10 minutes long? Yeah. Yeah. It's pretty impressive. The point is, you're not going to make BioShock Infinite. So find something, be the Portal developers. Be Narbuncular Trop. Find some core cool mechanic that is interesting, and that's what you're going to sell me on. If you want to make a cooperative spider web weaving game, that's never been done before. I have no idea how that would work or how it's fun. But it's never been done before, so, you know, that's what I'd focus on for the pitch. In your elevator pitch, you need to get me excited by your game concept in like 3 sentences or less. Okay. Webbed has been done. Damn it, really? Webbed. Really? Somebody did that. Yeah. Okay. It's not exactly what I had in mind. But yeah, okay, fair enough. Cool. That's hilarious. So in 3 sentences, you know, get me excited by your game concept. So in years past, it's been like, we want to make a game that has realistic reloading ammunition, like reloading of ammunition into guns. So most games sort of hand wave gun reloading. Gears of War, if you guys have played that, there's like, when you reload, there's like a slider that kind of moves across, and there's a range, and if you hit reload again when it's in the range, you do a quick reload. That's the closest I've seen to anybody messing with the reload mechanics, and so these students were like, we want to do realistic reloading. Half-Life Alyx, I guess, has realistic reloading in it. But that was like their thing. They wanted to have realistic reloading, and I'm like, all right, how is that fun? You know, like, if you have a shotgun and you've got to like somehow work the shells into the thing and slam them in, is that fun? Like, is it fun to reload more quickly? You gotta have to. It doesn't just have to be unique. It needs to be fun. Like, there needs, like, I would be like, yeah, I want to play that. Because frankly, I don't want to play a game where like I have to get out a revolver and take each individual bullet and, right? Like, I have to click on each one. Like, oh, hell no, dude. Like, this is tedious. Does Battlefront have a reloading net? Does it? Active reload. Square. So if you completely overheat, another bar appears with a small blue section and a smaller orange section. If you hit the trigger right when it's in the blue section, all of the heat will dissipate, allowing you to fire once more. If you land in the orange, you'll nail the active reload and get a short boost to your gun that lets you fire infinitely for 10 to 15 seconds. So, yeah, that's similar to the Gears of War system then. Yeah. Sometimes realistic isn't fun. Yeah, exactly. Exactly. It's like, you know, as much as we don't, as much as we kind of talk trash about like health bars and things like that, because in real life humans don't have health bars, you know, it's kind of like, do you want to play a video game where like you get shot in the shoulder and now you can't shoot your gun anymore, right? Because now your arm's like messed up. It's like, cool, that's realistic, but I can't play the game now. You know, like, all right. It'd be cool if I could like do something, but I've been shot, so, you know. Or in games where like when people die, they fall over and then you go over and stab them with some adrenaline and they go, oh, I'm 100% health now, you know. And, it doesn't really work that way, you know. Phoenix Project, your characters can have their arms ripped off and unable to use standard weapons. Is that a real thing? Video game conventions exist for reasons, yeah, for sure. Is that a real thing? Phoenix Project? A novel about IT. That's probably not it. Cheap time travel. Okay. Yeah, video game conventions do exist for a reason. And if you want to subvert a convention, like if you want to subvert it, if you want to have a game that has realistic damage, and some games have done this before, right? Like BattleTech, right? If you've ever played BattleTech or any of these kind of mecha games, Mech Warrior, right? You can get your arms blown off, you know? And come on, give me a shot of the game. Come on. Mech Warrior 5, which is an okay game. It's alright. It's kind of lame. Okay, here we go. So it's not lame. It's just kind of repetitive. So you got your armor status down here, and as you take damage, it'll turn red, and then they can get blown off. And so if you have any lasers on your right arm, well, you don't anymore. Your arm's gone. You know. And after you finish the mission, you have to pay to have that arm put back on. You know what I mean? Like, you got to actually repair all of your armor that got shot. And then if you lose a limb, that's expensive. And if your mech gets destroyed, that's very expensive. Mechs are very, very expensive in the world. And so you do missions, and like I'll do a mission and win, and then restart because I took too much damage and I lost money on the endeavor. And so I quit playing it because I got to a mission where my team was all optimized for like long range damage. Like basically I'd perch on a hillside and there'd be bad guys over there, and all of our long-range missiles would go like this, and just blow them all up. And this one mission, which was too hard for me as it was, we were doing fine, but you're just going along, and then it just spawns mechas in the middle of your people as just part of the mission. Just like, and there's a bunch of guys right next to you, and I just kept taking so much damage from it that I quit playing it. I uninstalled the game as a result of it. So that's a place where unrealism turned me off, right? Because mechs don't just like appear. Like they have to like come in on a drop ship and drop off and stuff like that. And sometimes when games are unrealistic like that, then that turns me off as well. Doom 3 had that problem where you'd clear out a room and then you'd leave and it would teleport a monster in behind you. And in a first-person shooter, there's kind of a convention that like you sweep a room and you clear it and then you leave and you know that the area behind you is cleared. And Doom, just to do the jump scare thing, would keep making a monster appear when you leave a room and then attack you from behind. And because everything's dark, you can't see anything, it was kind of lame. And they kept doing it over and over again, where you would clear a room, leave, and then a monster would be in there anyway. And so when games are unrealistic like that, that's not how, that's mechs don't just appear, like when they break our expectations in a bad way, then that was literally enough for me to uninstall the entire game. So, what about those mobile games that make you wait 24 hours to play again? Yeah, pay me to buy power crystals. Like every time I see one of those things, where like we've got a premium currency, I'm just like, nope, uninstall. There was some PC game where like it was like pay $5 now to get 100 power crystals, and I was about to uninstall it. Where it was like, psych, we would never do that to you. I was like, oh. We're this close away to getting uninstalled. I don't remember what game that was. It was like Undertale or something like that. Yeah. Just don't have your ammo storage yet. Yeah. Phoenix Point. Gotcha. Yeah. I mobile gaming had such promise, and I think the promise for mobile gaming has been entirely squandered. The reality of the situation is like I've never seen a killer mobile game. It's sad too, because like when flip phones were coming out and they started making games for the flip phones, I would sit there in my hotel in South Carolina because I'm on a business trip, and I'd have my little flip phone up, and there's like a little tiny dungeon thing, and I'm going around killing monsters and collecting loot, and I'm like, oh man, think about how great mobile gaming is going to be in the future, and now it's all, get a loot box, and it's like, get premium currency, like no, I don't want to play any of those games. My lord, it was so. There was so much potential. Like, just charge me $10 for your game, and I'll pay it. Put out a demo. I'll play the demo, and then charge me $10 to play the whole thing. I hate loot boxes. I hate premium currencies. All that nonsense. It's just the second I see it, I just uninstall the game. Genshin Impact, which is apparently one of the top selling games right now, is a loot box game. I'm like, nope, no thanks. The Lion King game on Game Boy. Yeah, it was deliberately made to be hard, from what I understand. Fearsome Power of the Gotcha. Yeah. Okay, so anyway, it's a little bit on realism, I guess. All right, so. Got landscapes, yeah. Okay, so what I want you to do for your pitch document is to come up with some interesting mechanic, like something new, something novel at least, that, it could be any genre. It could be a role-playing game, first-person shooter, puzzle game. I don't really care. Let's use Unreal Engine for it. Demonstrate your power of Unreal Engine knowledge. But just come up with some clever thing that nobody's done before. Or if they've done it before, we're going to do Pong, but it's going to be, I don't know, in the ocean, and there's going to be a fish that swims back and forth. I don't know, and so you can throw bait out there, and the fish will chase the bait, so you can do curve shots. I don't know, I'm just tossing out ideas. You know what I mean? Like, just have some twist. It doesn't have to be 100% off, original, but just some twist on it. Okay. All right. Make sure you guys know all this stuff. I think we can do math today. Maybe we'll just do math today. Let's see if time dilation. Yeah. All right. So we talked about this last time. Delta time. It's the time since the last frame. It's really important to do that anytime you do on event tick stuff. But there's other deltas as well. There's cursor delta, which is how far the mouse moved in the last frame. Gesture delta for how far the finger moved. Wheel delta, how far the mouse wheel moved. So all of these things use deltas, how far it's moved since the last frame. There's time dilation built into Unreal Engine. You can have bullet time where you shoot and the whole world slows down and a bullet comes at you and you go, whoa. If you do that, you can't really use hit scan weapons. You have to do projectile weapons, and then everything slows down. You can dodge out of the way. So you can move at full speed when everything else moves slowly, and that's used for like VATS. If you guys have played any of the Fallout series, when you engage VATS, it actually doesn't pause the game. Everything's actually moving slowly, just like 10 times slower than normal or something like that. So super hot, yeah. Well, super hot, I think everything's paused except when you're moving, right? Like if you don't move, everything's paused, and then as you move, everything moves, right? Something like that. So. Yeah, so that's actually a really creative use of time, right? There's, Braid is another. Have any of you guys played Braid? Braid uses time in a very creative fashion as well. Older version was turn-based for Fallout. You guys know what I'm talking about? Braid. Braid, the puzzle time-based puzzle platformer, yeah. The way that it works is that when you're moving to the right, time advances, and when you move to the left, time retreats. And so it's just a really mind-blowing puzzle game. It has a pretty good story to it. Yep. Highly recommended. $15 still. Jeez. That's impressive. Okay. Yeah, get it on sale. $15 for a 12-year-old game is kind of absurd, but I guess they figure at this point, why not? If somebody wants to play it, they're going to pay for it, All right. Yeah, in Unreal Engine, you can get the game time. You can get the real time of the real world if you want. You can get how long an audio's been playing for. So, for example, if a sound's been looping for 5 minutes, you can turn it off at that point. So, like, if you have a security camera that's rotating, you can get the time and do like a sign of the time, SIN, sign of the times, trig. You can take the current time, feed it into some sort of trig function, like sine or cosine, and set its rotation based on the sign, so you can have the camera moving back and forth like this. And you don't need to synchronize things over the network. You can do it locally if you wanted to. Maybe not in Unreal Engine, but you can do day and night cycles. There's a tutorial here that shows you how to do day and night cycles. Yeah, one big issue is that players will sometimes alt-tab out of your game, and that causes issues, right? So, in general, when you alt-tab out, you probably want to detect that and pause the game. If you don't, then what can happen is the delta t, which you're used to being like a 30th of a second, a 60th of a second, something like that, the delta t, the time since the last frame, could be 10 minutes. And think about how your game will break if delta t is set to 10 minutes. Like if you set the position of something based on, delta t times their velocity, Well, there's an old video game. There's a space game, and I would I'd hit the afterburner, which only lasted for a few seconds, and get up to an incredibly high rate of speed. Then I'll tab out and just like read a book for a minute or two. Then I'll tab back in, and I'm on the other side of the galaxy because it had me at a high velocity times a delta t of like 10 minutes, and then it's like, okay, well, your new position is over here, and it was just it basically allowed me to bypass all the tedious, just flying around an empty galaxy kind of thing at low speeds. I'd afterburn, I'll tab out, and then let the algebra do the rest for me. And then there's another issue with like physics. So the physics updates every frame, right? And so depending on how often the physics updates is how accurate your physics are going to be. So imagine a marble running down they have these things at like science centers and stuff like that. Yeah, these things. And so you drop a marble in it, and it kind of goes down the thing, and it'll kind of go like this and like this, and as it gets closer, it spins faster. Trying to simulate this in a video game is really, really hard. And and the results you get are going to be based on your frame rate, because the more often your frame rate updates, the more the velocity will approximate a circle. And the lower your frame rate, the more they'll jump in a straight line, and you will get different answers to where the marble should be based on the frame rate you're getting. And that's rough. And so the best answer here is don't do that. Physics is one of those things that's really hard to get right in a video game. Physics is just really, really hard to do well. There's always physics bugs. There's always scenarios where, like, if you take three objects and push them next to each other, the physics engine is like, I don't know how to deal with this, and they'll explode. If you've ever played Oblivion and you have a table and a plate and a piece of meat on it, the thing will start rattling like this, and then the meat will go flying off across the room. Yeah. Have you guys ever seen that, like Oblivion or Skyrim? Like when you walk in, if something isn't moving, it doesn't run the physics on it, but if you touch it, then it starts simulating physics on it, and these things will start going and vibrating, and then the fork flies off this way and this flies off that way, because it's trying to simulate gravity and pushing, and then the table's pushing back up, and it doesn't know where to go, and then it goes like that. Paintbrush, yeah. It's really quite funny and frustrating too, because my wife liked modding Oblivion, and so her mod was just making a house, and so she would just put crystals in little cups, that would glow, and put food out and stuff like that, and you'd walk in and it'd all be fine, and then the second the physics engine started running, things would just start and the table would explode, and just physics engines are really hard to do well. They just really are. Okay. So the delay node, we've talked about that before briefly, which is to say after 2 seconds, do something. And then the blueprint will wait for 2 seconds and then continue executing. So the blueprint will not do anything else while it's doing that. So if you attach this to event tick, no more event ticks will come in until the delay finishes. And so that's a really nice way of just saying every 2 seconds do something. You just slap a delay onto an event tick, and then, every 5 seconds, have the AI wake up, see if it can see the player. If it can't, go back to sleep. And a timer is sort of a better, way of doing this. We've talked about this before. So there's a documentation on timers here. But you do things like you can pause the timer, you can restart the timer, and the timer can call a function every 2 seconds or whatever, and it'll just run, and then you can pause it and then restart it and stuff like that. So timers are one of those core concepts in video games, to have something happen repeatedly. And the sort of lowbrow way of doing it is event tick with a delay on it. The timer functionality in Unreal Engine is kind of the better way of doing it. I know Hazelton's messed with it before. Then we have this thing called a sequence. And so sequence is it's not really. Oh, that's cool. That's nice. I have seen this before. Huh. Right. So I installed some assets into my game engine, and there's some test maps that come with it. That's pretty cool. I like that. Okay, so if you want to do a blueprint of some sort, let's see here. It's just a mesh. So when we take damage as the player, when we die, it's going to first play a sound in 2D, then it's going to hide me, then it's going to set dead to be true, it sets my health to 0 so it doesn't go negative and mess up the HUD, sets my walk speed to 0, and then it should probably have a delay and then restart. Now instead of doing this thing here, I could have set up what's called a sequence instead. And a sequence is just a way of sort of reorganizing your things like this. In fact, so it first plays a sound, then it sets the actor to be hidden, then it sets dead to be true, then it You guys understand? So it's just a different way of organizing your code. It doesn't do anything we couldn't do before. It's not even like a callback. It just does this one, and then after that one finishes, it does this one. So rather than needing to attach things out horizontally, which we normally do, you can kind of lay them out vertically like this. And that's useful if you've got like really long chains. So like, let's say this really long chain here is just like doing a bunch of particles and stuff like that. And then when you get to the end of all the particle stuff, then you're like, okay, now we're gonna, kill all the goblins near us. So you have a long chain for that. So you can sort of like lay out your code in sort of a more sensible fashion. Okay. Yeah, it just keeps your code neat. It doesn't do anything we couldn't do before. Let's just make sure this. Oh shoot. Nope, not you. Not you. Not you. Where is my map? Where's my starting map? Are you? Third person BP. Oh, it's under third person BP. Okay, that makes sense. All right. There it is. Yeah, okay. All right. So let's see if this works. Okay. So yeah, does the same thing as before. All right. You understand? That's the sequence. And then we haven't talked about timelines yet, have we? Have we talked about timelines? Okay. So timeline's kind of cool. So let's close out this stuff, and I'll try to figure out what the hell is going on with this thing. Physics body. Army of cats, to my command! Alright, I've got this target designated. Alright. You're in trouble now, Goblin. Heat-seeking rocket time. Alright. Target designated. Okay. Alright, let's talk about timelines. Let's say we want to make a door. Okay, doors are one of those things where that's pretty texture. Doesn't look good when you get too close, but like from right about here, it looks really nice. Let's say you want to make a door. Doors are one of those things that are like infamously hard to do well and easy to do badly. So the most simple door in the world is like a Star Trek door. You walk up to it and like it goes, you know, it opens up, you walk through and it goes, and it closes down. Even still, even with the simplest door, which I'm going to make for you in the next 20 minutes, even with the simplest door, having it work with AI is like, like, you got to teach the AI, like, you got to, you know, if you're trying to path to the player, you got to walk up to the door and, like, have it open and then go through, and what if the door's locked? Or what if there's somebody in the door, you know, like, you know, what if somebody's trying to close the door while the door is opening? It gets stupid complicated really fast. But for at the simplest level, to make it just a bad door, we can do this. Yeah, and then in some games, like in The Last of Us, you know, the people walk forward and they grab the door handle and they open it, you know, or in Red Dead Redemption, they come up and they slam their way through the door, which is a very clever way of not having to mess with the door handle, right? They just walk and they go like that. That adds even more exponential complexity to it. Like, it gets real complicated real fast. But we're going to do a stupid door. All right. So like maybe we got a place here, put a door in it. Okay. So I'm going to make a new blueprint class, and this will be called, it'll be just an actor. Okay. And this will be called, I don't know, stupid door or something like that. Okay, so I'm going to drag out the stupid door here, and there we go, and hit end and drop it on the ground, and right. Okay, so now I'm going to open up stupid door, and so stupid door is just going to be like a little, I don't know, Star Trek door or something. The easiest one would just be a box, right? It just slides into the ground or something. Maybe we'll just start with that. We can do a Star Trek door that like, two PCs at a war for the door, one trying to leave, one trying to enter. Yeah, I feel that, you know, I feel that. All right, so let's just add a box or something. Let's add a cube, and let's take a look at what this looks like in the world. So I'm going to actually have it like this. So I'm looking over here at my screen so I can see what it's going to look like in the real world. I'm going to drag it up to here. Okay. All right. And so the scale on this will be, that way it's forwards. That one. Okay. No, that's forward. That way's forward. yeah, in the forward direction, 0.1. Okay. And then in the width direction, okay, let me rotate this in the world that you can't see. Okay. And then the width of it will be 2 meters. That's fine. And the height of it will be 3 meters. And then we will pull this up. So it's about a meter up. Nope. A meter up. Meter 50 up. There we go. So this is what it looks like. This is what it looks like over in the real world. We've got this door here. It's maybe a little bit too tall, but that's pretty good. So it's going to be blocking. It's going to be blocking our doorway here. And what we're going to do is when we walk up to it, we're going to have it. We walk up to it. We're going to have it just slide into the ground. I guess we're making a stupid door here. Okay. Yeah. It's really hard to make AI work with doors well. All right, so we'll slap a texture on it. Material. It's a cat door. Why not? Let's do that. Okay. Nah, that's not professional enough. Let's do. Let's do like oak or something. Okay, so that's what it's going to look like. That looks pretty good, I think. Okay. So now, what do we need to do if we want to have? Oops. If we want to have the player, when they walk up to it, we want it to activate and we want it to slide into the ground. What do we do? What do we need to add? What's called? Collision sphere, collision area. Yeah. With a box collision. And I don't want it to be a child of the cube, because if it's a child of the cube, the collision will actually move with it. And I actually want to reparent it to the scene root. So this box here, drag it up here, and then I'm just going to kind of eyeball this to there, to here, and out a fair bit like this, maybe. So when you walk up to it, a little bit, like 1.5 meters, it'll slide into the ground. Okay? And so now if the cube moves, because I unparented it, right? Now the box trigger will stay there. Okay. So what this looks like is this. And then you can take a look on here and see if that seems reasonable, which it does. I need to walk up to about here, and then it'll slide into the ground. Okay. So coming back up into here, got this, we got that. Yeah, that's about it for the blueprint. So over here in the event graph, we don't need event tick. We don't need begin play. Maybe we do. Yeah, I'm gonna delete it for now. Don't need event tick. So what we're gonna do for event actor begin overlap, what's the first thing we always do? Let's see if it works. Print. Let's print string, because if you do not have I call this ding dong, you know, hit the door. Because if we do not have these things set up right, like cube needs to be set to generate overlap events, and you know what I mean? Like if something's not set right, then I'll snap it over here and go over to the map, save, go over here. Okay, so ding dong. Okay, cool. So it works. And there's one other event we need to cause it to go back up. Actually, I kind of want that box to be a little bit bigger. It's just a little bit small right now, so I'm gonna make it a little bit bigger. Okay. So when it begins overlapping, we want it to slide into the ground. And then when the player leaves, we want it to go back up, right? And so what do you think that event is called for ending overlap? Yep. And so when they leave, again, we will just print string, and we're going to just say goodbye. I've been burned by enough weird bugs in Unreal Engine that I just always just double check. Ding dong, goodbye. Ding dong, goodbye. Okay. And I think it said ding dong because I think one of the AI walked up to it from behind and it said ding dong. So we're going to have to decide, do we want the AI to be able to open the door? What do you think? Do we want the AI to let itself out? Yes or no? I don't know. The AI should? Okay. All right, let's do it. So when we begin overlap, what we want to do is we want a timeline to play. And so we're going to add a timeline. And what a timeline is called door opening animation. Remember how I told you there's like 5 different ways of doing animations in Unreal Engine? So that's, you know, I wasn't lying to you. So when we begin overlapping that box collision, these things don't line up, do they? It's unfortunate. It will start playing the animation, and when we leave, it'll rewind the animation. Okay. So how do we make an animation out of this? Well, we double click on it. You guys see that? Double click on it. And then we get a blank screen here. What we need to do is add a float track. And so what this is going to do, it's going to say over time, over how many seconds, what the position of the door should be. And the position is, we could do this as a vector if we wanted. If we wanted it to move in the X, Y, and Z locations, we could have it, I don't know, spiral up into space or something, which would be kind of cool. I don't know. But we'll just do a float track for now. That's just, it's going to output a single number. And so we are going to add a point at 0, 0. And you want to make it 0, 0 like that. And then if we zoom out a little bit by mouse wheeling, you can see that this is seconds. And so how long do you think it should take for a door to open? What do you think? Half a second? 5 seconds? Depends. What do you want? How long do you think it should take? 2 seconds. Okay, cool. So in 2 seconds, we are going to add a key, and the length of this timeline we're going to limit to 2 seconds, so it doesn't keep going past it. And this key is going to be at 2 seconds, and its value is going to be 1. The reason for this is pretty common, is that this number here is going to represent how far open the door should be, and we could even give it a name if we wanted to. But it's going to be basically how far open, what % open the door is. So at half a second in, it's going to be at, you know, a quarter open, right? And a second in, it's going to be half open, right? And you can have these things be on curves. You can add additional keyframes in here, where you can make them like open and then close, and you know, you can do all sorts of like, you know, you can make it open and close and open again if you want to, like a malfunctioning door. I'm just going to have it be simple. It's a stupid door. We're just going to do a stupid animation. Okay. And yeah, that's basically it. Save it. Rename it as %open. Okay. And then we come back into the event graph. And now, check this out. We now have a %open. And so every tick, this is like an event tick thing here. Every tick that this thing is playing, it doesn't play when it's not playing. It only plays when it's opening, but it's basically an event tick. And it is going to, let's just start off by printing string so you can see what's going on here. So every frame, it is going to print the percentage open it should be. We haven't done any physics yet. We're just printing it, right? So compile, save, come over here, play. And, oh, it's the AI. Thank you. The AI is messing with it. Okay, I'm going to turn off the AI. I'm sorry, it's too confusing. Okay, so if the other person cast to main character, for you guys, it's going to be third-person character, like that. So I'm only going to allow the player to activate this thing. Sorry, it's just too confusing right now. Yeah. Control W. Okay, let's try this again. And there. Okay. Play. Okay. So now when we walk up here, you can see it goes 3, 4, 5, 6, 7, 8, 9, 10. I walk away, it counts back down. Okay. I walk up, it counts up to 1. You see that? I walk away, it counts down to 0. And if I interrupt the process, it kind of smoothly, you see how, like, trying to open a door here. Okay. So when I walk up, it goes up, and then when I walk away, it goes down. You see how that very smoothly transitions up and down? Okay, so all we have to do now. So does that make sense to you? Like, basically, we've got this timeline here. Every tick, it's going to tell us what percent open the door should be. Okay? Does that work? And then there's another thing that happens when it finishes. Like, we can print doors open now or something, or more like, you know, when the door opens, and we can trigger, you know, a particle effect or something. So now you just move the door's location. Yeah, that's it. So every frame we are going to set location. Of cube. Let's rename the cube. Let's call this the door. And we'll call you the collision boy. Okay. So we are going to set world location. We can add an offset to it to do it that way. Yeah, I'll just do a set. Which way do I want to do this? We'll just add an offset, I guess. So the door is going to get an offset. And then this is how far it should move. Nah, let's not do an offset. Let's just set the location. Oh, shoot. Too much. There we go. Okay, so we will set world location of the door. And we're going to give it a new location. And this is why I said I thought there might be something I might need for begin play. For begin play, I'm just going to write down my original location. So I'm just going to get world location. Get is not a thing. Get world location for the door. And this I'm going to promote to a variable. And that variable is going to be original location. So what I'm doing is I'm basically saving when I'm created in the world. I'm going to write down where I was originally. And the reason why you want to do this is, like, if you add offsets and you add up 10 times, you add down 10 times, you're doing floating point math. And so every time you add and subtract, there's a little bit of error. And so your door might not close all the way and stuff like that. So it's usually a good idea to actually just write down what your original location is, and then you can just use that. So my new location is going to be, and we should probably make another variable for, like, how high up it should move, maybe. Right? Or how far it should move or something. I don't know. Or maybe I can get my size. Like get the size. Get my size. Size of the geometry and absolute size. 2D structure. Split. Let's just make a variable as how far it should move. Okay, so let's make a variable, and this variable is going to be called how far to move. All right, and then we'll just eyeball it, I guess. Not a vector. Let's make it float because we're only going to be moving up and down. So how far to move? And it's about 3 meters. So I'll make it 3 meters. Okay. All right. So okay. So the world location is going to be set to our original location, and we'll split this because we're only going to be messing with the. We'll split this one because the original x, the original y. All we're going to be messing with is the z, right? And so the z is how far up it is, and so we're going to take whatever our original place is, and we're going to have the door go down, I guess. So we will take its original z location and subtract from it what percentage open we are times how far to move. A little mess of spaghetti here. Not happy with this. Okay. So if the original z location is 100, then as it goes from percentage open 0 to 1, it's going to start subtracting 0, 10, 20, 30, all the way up to how far to move is 300. So when we're 100% open, it's going to move down 300 centimeters from its original. And that should do it. There's always different ways of doing algebra and stuff, of course, but let's try this out. There we go. And we walk through and it closes back up. Come on, AI. Come get me. Come get me, AI. Ah, alright. Uh-oh, I'm gonna die, aren't I? Can I walk through? Ah! I think the AI can't path through it. That's what I'm talking about. Like AI indoors is just like, ah! AI just has issues with doors. But there you go. There's a door. It's 3 o'clock, so there's maybe we'll have that be a little thing as well. So for Thursday, make a door. Just slides open, slides closed. Use a timeline, demonstrate that to me, and yeah, and then we'll just say on next Tuesday, write a pitch document to me. Okay, that sound good? All right. Thanks for coming out, everyone, and I will see you next time. Peace.